is up, everybody? I've already got the glove on. We're ready to draw. This is the second episode of CSGFlix, which is really about building a streaming service from scratch. This is sort of an insane project I got started on when I was talking to a few people and they were saying, oh, how does streaming work over the internet? And, we were hanging out in Alt F4 stream and there's a lot of confusion. It was one of those things that I'd been doing it for a long time when I was working at Netflix, and you don't think about it, when you're really close to it. But when you want to get a little bit further away and you're trying to explain it to someone, you're like, whoa, I've been really deep in the ditches for a while, and this is more complicated than I thought it was. So in this series, I'm just trying to stick to mostly the basics. So we're not getting into super advanced topics. The goal here is to do something that you can get a sense of how it works. Any of the topics that we're going to cover, you could go way deeper on. I mean, you could do all sorts of work with them, but I'm aiming for kind of a high level. For those of you who caught the intro session last week, it was, we're simplifying things. We're not doing something as complicated as what Netflix does. We're only supporting one device. We're trying to go for the browser. We're going to have the browser, so you have to watch video on the browser, and that's already a little bit unrealistic. But if you have one platform, it's a lot easier to support. We're only going to support one type of browser, but suffice it to say that it pretty much works that way for everybody. So we're going to build a simple version of the servers, and we're going to kind of go from there. So those of you who checked out the tools we were building yesterday and the day before, that was I am going to be making that a regular feature, so you'll be able to code with me during the session. So gather your points. We're going to make them useful in a future stream. So in the meantime, let's get started with CSGFlix. So my goal here is we're going to be doing a bit of overview in sort of the first. So this is episode 2. We're going to be talking about video tonight. So this was the let me see here. This was kind of where we left things at the end of the first session, and we did the overview, and that was kind of cool. So this time we're going to be focusing on video. Depending on how the session goes, we might get to audio too. It's kind of a similar case to video, a few differences, but same general idea. So today's session is really about how we're going to pack files up, and we're going to be sending them to the browser. So we'll get into these other topics in the future. I'm hoping to do maybe 2 of these a week. The UI was basically the original Friday session I had scheduled anyway. So we'll see where we get with that. But it'll be at least every Wednesday until we get through this, and probably a lot of the Fridays as well. All right. So without further ado, I whipped up a quick little intro for all of you, which is based on, yes, the last session, the episode 1 session. So let's take a look at that. Okay, a little bit shorter than the normal intro video, but we can we could do. I'm working for you. That's all you need to know. Okay, so we're in episode 2, and hopefully, unlike the other thing that's referred to as episode 2, this will be terribly interesting. Okay, so we're talking about video today, and what is video sort of like at a high level? I mean, video hasn't really changed that much in a really long time. I mean, so video is basically just a let me make that a little bit bigger. It's basically just a set of pictures, and if you play these pictures fast enough, so this is picture 1, 2, 3, and if you play these pictures fast enough and just sort of keep swapping them on top of each other, then, and you do that really fast, then it sort of blurs into an image that we believe is a motion video. So if we start off and we have our dude kind of chilling out here, and then, you know, he sort of raises his hand a little bit, and then, you know, he goes, and I know I really went to art school. No, I didn't go to art school at all. But so if we get this little like hand animation going, and we play these pictures fast enough, and we put them right on top of each other, then it sort of blurs at some point, and the human eye kind of gets stuck with this persistence of vision, and we see sort of the previous frame. It's blurring faster than our brain is sort of like capturing it, and that's kind of, they call that flicker fusion. So that's sort of what we're aiming to do when we're doing video. We want to make sure that we're throwing these pictures, which we're going to call frames, and we want to make sure that we're throwing these frames at the user fast enough to maintain this illusion of flicker fusion. And as long as that happens, then we get this nice seamless image that something is moving, even though it's really just a set of pictures. So our first view into the world of video is to talk about groups of pictures. Okay, so that's all fine. Audio, on the other hand, is a little bit different. So we can't really see audio, but, you know, we can imagine it sort of as a frequency graph, and, you know, who knows what this looks like. But and what this is this is sort of like looking at a series of pulses over time. And if these pulses are played, even though there's like little gaps in here, if these pulses are played fast enough, then again, it creates that, it's sort of like the equivalent of this flicker fusion. We get this sort of like aural fusion. I'm not actually sure that that's the real term for it, but you heard it here first, if not. And as long as we take all of these different pulses, so here's pulse 1, 2, 3, you know, we just kind of keep on going. And we do that fast enough, then that'll blend into a nice streamless, you know, seamless waveform, which will trick us into thinking we're hearing somebody speaking, or some sound effects, or a car crash, or whatever happens to be playing. This type of encoding, so over here on the pictures, we were talking about groups of pictures. Down here, we're talking about all of these pulses, and this is pulse-coded modulation. So as long as we do these pulses really fast at a consistent speed, the breaks between these things have to be really, really regular, otherwise the illusion gets broken. Then it'll blend into one nice like aural experience, and we'll end up getting the impression that we're hearing this thing live, even though, you know, who knows what's really live. All right, so that's basically our target. So when we want to work with a video that we're going to play over the internet, it's really packaged into these two parts. You know, we're going to have to make some sort of like box for all this stuff, and we're going to have to get that turned into a whole pile of bits. And we got to get those bits, you know, which are ones and zeros. And we got to get those things from the server or wherever they're hosted. This might be a CDN, or, you know, this I can spell too. This might be a CDN, or, you know, this could be like, you know, just a single web server, which is what we're going to be doing today. Or, you know, and then we need to get those shipped off to the browser. And I'm running out of space there, but if we work that right, then we get that stuff over to a browser as soon as the user requests it. So they say, I want movie 1, and movie 1's bits get delivered down. If I want movie 2, then I have to go to a different group of all this stuff, and I have to send that back. And here's movie 2. And so this person could be watching movie 3. And this is pretty much the experience that we're going to want to create. So today we're focused on how do we put these things together? And I'm going to try to keep the packaging format of this box in a familiar packaging format for all of you. And this is a little bit insane. In a real production system, you would never actually pack video and audio in a JSON format like we're going to do today. But the nice thing about the JSON is I think a lot of people that are going to be watching this stream are probably familiar with it. And it makes it very, you know, it's text readable. So it should be very easy to sort of see what this stuff looks like. So, okay, well, that's really neat. What do we do sort of as we move along in this sort of motion capture world? So we have like a frame, and I don't really like that color. I think we're going to go more on this color. Chat, let me know if this is too dark to see. So we're going to take these frames. So here's frame 1, here's frame 2, and so on. And we're going to notice as we're putting this together in our simple animation that I can actually draw, that the majority of the picture doesn't change. Like basically very little of this entire image, like this is really just a single image, and very little of this entire image is changing from frame to frame. The only actual part that changed was just this little, actually let me let me highlight that a little bit better. This little part here is the only thing that actually changed between, you know, frame 1 and 2. And that, if I extracted just that, would literally just be like, okay, delete, actually here, you know, that's again probably a simpler thing with color. Delete the arm being here and instead go with the arm being here. And if I send this thing, and this is sort of like this image 1 minus image 2, and so I can just say like, okay, just give me this delta part. This we're going to call a delta. So this would be a delta frame. In this case, I'm only sending the part that changed. So this by itself is totally meaningless. I need to have frame 1 here in order to be able to build frame 2. But if I have frame 1 and I sort of add frame 2 delta back onto it, then I end up with, you know, well, this is actually the delta here. And I put this together, combine it with that, I end up with this again. And that is wonderful because very little data needs to be transferred. I mean, almost all of this stuff is just going to be zeros. So we really, if we want to really not send a lot of bits, it's very nice to be able to just calculate like how much of this image is actually different. I could explode the entire thing out and just, you know, send an image every single frame. This gets very expensive because I'm literally sending all of the bits that are in the image every single time, regardless of if they changed or not. I have to send all of this data, which, you know, on a typical image, this could be like quite a lot of stuff. But in this case, in this delta case, I don't have to send that much. So this, to sort of borrow some terms that we're going to use, this is basically an image. This is an image type frame. And this is going to be a delta type frame, which they're going to call the standard term for this is a P frame. But this, I'm going to call it a delta frame because I think it's a little bit easier. P refers to prediction. So it's just saying like, okay, if you reassemble this whole thing, you're predicting what the next frame is going to be based on this difference. You can use different ways of calculating that, which is sort of like, that's the wealth of video codecs out there. But for our JSON example, which, you know, we're not really trying to build a production video format using this, we're going to just refer to these as sort of the delta frames. But if you hear me say P frame, that's what I'm referring to. There's a more advanced version of this, which we're going to get into in the next class when we start talking about compression. And compression is really about like, you know, how much do we have to send down to the browser in order to be able to keep this visual experience like nice, fluid, and quality. There's only one other attribute that we're going to have to worry about as we're doing all this, and that's we need to have a sense of how many bits are there that we're going to be sending. So if this is like kind of like a small picture, and this is that at a much larger scale, there's a lot more data, or, you know, as you might know from cameras, there's a lot more megapixels in something like this, which refers to like, you know, how many dots there are in the image than there is in this. This is going to transfer really quickly, but this thing is like, you know, it's going to be a little bit slower. It's going to take a lot more memory. So it's very important that we know like how many bits are going this way. How, how wide is this image? How high is this image? I'm going to call this one a big H and this one a big W. But, and there's sort of some standard sizes. Most of them use the H dimension, the height, to refer to the resolution. And they sort of ignore the width because the ratio between these is kind of constant. So you probably heard this as like, the computer people here are definitely going to know all of this stuff. But we might have something like 480, if we're talking about television type formats, 720, 240, and this P is referring to progressive scan. So this is just number of pixels kind of going top to bottom. 1080, and then something kind of strange happens at when it gets to 4K, which is they switch over to the horizontal dimension and they drop using the vertical dimension because this number is a lot bigger than this number, but it sounds like it's 4 times better, but it isn't. Okay, so we're going to be using these kind of sizes in this series. I'm going to focus today mostly on this because we're not going to be doing much compression, so there's going to be a lot of data. If you don't compress an image, it's actually quite large. Now, in these images, we are going to need to spell out every single dot from the top left all the way down to the bottom right in this image. And how are we actually going to spell these things out? So I'm not talking about a delta frame here. I really shouldn't be drawing on top of this one. We should be drawing on top of this guy. But how are we going to format this stuff? Well, this very quickly gets into a complicated discussion that isn't going to be that important for today. But what we're going to look at is basically all of the bits that are in this image are going to be packed into groups of 3. And these groups of 3 are your standard RGB. So we're going to be using Rgb Color Space. And this refers to red, green, and blue. And that's sort of on the assumption that you can put these things together. And let's pick a nice red here. And let's pick a nice blue. And if I sort of mix all of these colors together, then I'll end up with the intersection of this stuff. Now, obviously, it's not actually a Venn diagram like this, but, if I mix together some of these colors, I'm going to get, different combinations. And between all of them, I'll get a pretty decent color space that I can use. So we need to be careful about how many bits we specify for each one of these. And that is sort of our bit format. So if we're just going to take like full color images, which are made up of equal parts of red, green, and blue. And each of these is going to be 8 bits wide. So that's also just a byte in modern times. So we have 8 bits of red, we have 8 bits of green, and we have 8 bits of blue. And this is referred to in video as RGB 888. It's also called in regular kind of computers. Oh, look at that. RGB 888, which is in computer slang, we can just add together all these 8s, and we usually refer to this as 24-bit color. Now, this is kind of an awkward size for a computer because computers like to deal in things like 32 bits because they're typically, working with based on their history, processors, were 8 bits wide, and then they were 16 bits wide, and then you put 2 16-bit, words together, and then you end up getting a nice 32-bit number, which would look more like that versus the 8s where we would need 4 of these 8s. So what do you do with these 4 8s? Well, it turns out the browser very much likes this format. So it treats this as RGB and A, and this A thing is kind of a fake dimension, unlike the red, green, and blue. We don't just mix A together. A refers to alpha, and alpha is really about like how light or dark all of these things are. So I can take the alpha and I can just mix it into the RGB values, and then I don't need it. So that's really more for like, if you're programming, or if you're building like an image manipulation program. then it's nice to be able to just quickly set alpha and just ignore Rgb. But for our purposes tonight, we don't care about, we're not building an image editing program. We're just trying to display stuff on the screen as fast as possible. And alpha communicates no additional information. So we're not going to add the alpha channel in at all in anything that we're working in. So that means that when we're working on the server, we have to be really careful about this, because on the server, we're going to work on this kind of 24-bit, 888 color space. But when we're on the client, we're going to need to expand that to this Rgb space. And that's going to cause some JavaScript gymnastics, because if we leave this alone, it'll start off as 0, which means this is totally dark. This is not seen. So this will just show up as black. And that showed up a bit when I was trying to do this, when I was prepping this last week. So we're going to try to be careful, and we're going to put the maximum value in here for this when we're expanding it, which for 8 bits would be 0 to 255. And that's cool. So as long as we just remember to put that in there, we shouldn't see just black. So if we see just black after we're expanding this thing, hey, remind me in chat, go, hey, guy, yeah, you probably forgot that alpha value. So we'll see how far we get with that. All right. So let me know if there's any questions on that. I'm going to keep going, but I'll try to answer them as we move along. That's really the important stuff. There's a lot more that's going to go on in the future when we start talking about compression, but that's really another topic. So I'm going to try to stay light on compression for today. But if we're talking about JSON as our image format, then we're not too worried about compression to begin with. So great. Well, that's all fine. That's our theory. So we get the pictures to show up on the browser fast enough, we're good to go. Here's one picture. We throw a bunch of these. That visual perception threshold that I told you about, that happens at around like 8 to 15 frames a second. That's that flicker fusion. It starts to blend depending on the person. So for video formats, we usually want to be safely above that. We want to be doing like 30 frames a second. Old film was 24 frames a second. Modern games use 60 frames a second. It doesn't cause any eye strain, but we're just gonna stay with 30 frames a second because I think it's a reasonable amount of data for us to be JSONing and packing and unpacking. All right, so what do we got? We have this directory that we created last time, and in there we had episode 1. We did our overview, and we started building a player, possibly using mscript. And I'm now of the opinion that we can do this with just JavaScript, so we're going to try to do it with just JavaScript. So let's start our episode 2 directory, and in here we're going to make we're going to make our Flask app. So this there's one thing, what I totally forgot to mention, and I should probably say that before we cut back over to this code, which is we do have a plan. So let me just cut right back to that for a split second, and I'm gonna just tell all of you that we don't want that C. So yeah, cool. All right, so let's say that tonight the first thing we're going to want to do, and actually that looks too dark, so let's do something a little more gray. All right, so this is going to be our plan, and it has a line under it, so that's a serious plan. Okay, we're going to deal with our video as images. So our first goal is going to be to get a set of images that we can work with, that we know that when we put them together right, we end up with a video. Our next step is we're going to try to get one of those images to load on the browser. We're going to start very simply. Now, assuming that all goes fine, we're going to take a look at Delta. We might have to come back to this depending on how much time we've got. I'm a little worried about the amount of content we got to get through. So this is like the Delta calculation. And then we're going to take the delta and we're going to put it back together. So this is like the apply. And that's where we're going to actually merge the delta image with the with the image that it refers to. So that those two are kind of a little bit more stretch. And then we're going to play this on a timer. And if we hit that at 30 frames a second, then we're going to be doing pretty well. And reach goal, if we get there, is a little bit of audio. So in this case, we'll be trying to do the same thing, but we'll be stitching it together for PCM. So that's basically our plan. So I'll leave that up to remember. Oh, and I totally forgot to give you that while I was drawing it. So anyway, sorry. The plan is over here on the top left. So I've got this, video, image, maybe some delta stuff, play timer. Cool. We have effectively, today we're not going to be very bandwidth constrained because we basically have infinite bandwidth from the computer to the computer. But as we get to the real internet, which I think is episode 5, then we'll start to worry about, we have to begin worrying about how much data we're transferring, but today it'll pretty much work no matter how many bits and bytes we cram around, as long as the CPU can keep up with it. Okay, so we're going to try our pure JavaScript player. And our pure JavaScript player is going to need, there's a little bug that I've just got to fix in my Flask app creator tool, which is that this thing is the wrong path. I need to get this, oh, you know what? I totally forgot forgot to run screen here. So let's go into screen. And let me just fix pip real fast. And that will mean that we need this directory, which is where we are. B0 bin Python. So this is just to make our virtual environment work and to make sure that's all good. And if we got that right, I should be able to install things, and it's gonna, you gotta explain. Okay, good. So we don't get an error we're getting an error that's saying we didn't specify anything to install. Tonight we're gonna need 2 additional tools, which is we're gonna need to be able to work with images in their raw format. So we're gonna use pillow in place of pill, and we're going to need NumPy, the Python numeric library. So we're going to treat that image as basically a bunch of bits that are together in an array. Okay, so those get installed, we're good to go. If we wanted to just check that this is all good, bug aside, we can go do that. And if we go log into it over here, we have our basic template is waiting for us to get to work. Wonderful. Well, let's get to work. Before I cut right into the code, our first issue is we're going to need a video to work with. So what I did last week for the overview, I took a video, I recorded the video, and I dropped it in our assets directory. So this video, I've got 2 videos here, and it's the same piece of video, but this one is 30 seconds long and this other one is 10 minutes. So if we worry about if we run out of video to work with, we can always switch up to the bigger one. So one key thing that I mentioned in the overview last week is that streaming is different from downloading, because in the case of downloading, you're sort of waiting for the entire file to come down and then you start playing it, which in the overview I explained like that could take forever with a really high resolution. But in the case of streaming, we want to be sending the bits basically kind of as fast as the internet connection to the user can handle, and, within reason, and up to the resolution. But we want to be able to start playing as quickly as possible. So that it matters to us, how many bits we send. So we're going to start with a low resolution version to begin. This video itself is it's 720p. So we're going to be working with smaller video format so that we don't have to send too much JSON. So let me just copy that over. So I'm going to come here into the static directory and I'm going to copy movie 1. We're going to take the smaller image here. Now this MP4, it's packed in a normal industry format, and that's not how that's kind of what we want to talk about today, is how do we get these things into compressed formats. And MP4 does work on similar principles to what I was talking about with a little bit more complexity. But we're going to go back from that. We're going to take this MP4 and we're going to unroll it. So the way we're going to unroll it, we're going to use the Swiss Army knife of movie stuff, FFmpeg, and which, you know, I didn't want to build FFmpeg 2, you know, to deal with MP4 for tonight. So we're going to basically just take this movie format that we have here, and we're going to knock it down to this 426 by 240. So this is 240p, using the same width ratio as would be in the original image. The original image, or the original video format, if we look at it, is so this is 30 frames a second, and it's 1280 by 720. So there's our 720, and 1280 is the width. So if we look at that from a ratio perspective, so if I take 1280 and divide it by 720, it's 1.7. So if I do that with my 426 and I divide it by 240, it's close enough. Okay, so one of the constraints here with FFmpeg is that it has to be a round number, so I had to slightly push it on one side, but it's pretty much the same aspect ratio. So the width to the height is the same. Okay, well, let's take that video and let's knock it down to that size that I just mentioned. So we're going to go to 426 by 240. That should be a nice small file size, and we're going to label it as, this is the 240p version. Okay, so FFmpeg does its thing, and we take a look at our file sizes, and you see that movie 1 is, you know, kind of big at 9.1 megs, but at 240p it's only 560k. So you can see that resolution affects file size drastically. So our greatest compression that we're going to get is just to take the image and scale it down and not send as many bits. But that's we can always in the browser scale it back up, but it'll start to look kind of pixelated. We're losing some information. But if we don't want to start off with the highest fidelity, but we want to start off quickly, that's a lot less bytes to transfer to the user. So based on people's internet connections, that'll give you the ability to start playing video very fast. We're going to be working with 30-second chunks of video. So if we need more chunks, we'll just grab them from the rest of the video. Okay, well, that's my source. Now I'm going to take this format in this MP4, because we're not going to be delivering just MP4, and we're going to unroll it. So the first thing I want to do too is, there is one part that I didn't mention, which is that I also want to extract the audio part. So in this case, I have my movie. We're going to take the same source movie, but this time we're going to set the video codec to none. So it's going to drop the video, and we're just going to take the audio exactly as it is in this original file. We're just going to say copy that as is, and extract that into another file, which we're going to call movie1.aac. Turns out in that MP4, it's encoded as AAC, which is basically an MP4 Apple format. Okay, so now we have our AAC file, which is just the audio, and we have our MP4, our smaller size MP4, which is just the video. Well, actually, that one has the video and the audio, but you know, for now, we don't have to worry too much about that, because we're going to go making up our own image format. Now, I can't work directly with this AAC, so we're going to turn that into a much more commonly used and easy to use in Python format, which is going to be a normal WAV file. So this is like a very old audio format. Oh, and hey, what's up, 715209? How are you doing? And SS Uni. Oh my God, there's a clip for you that I need to show you from yesterday's session where I was like, SS Uni would be having a heart attack if she saw this. And we were coding, and somebody from the stream jumped in on the code session, and they were like, SS Uni loves programming in Python. Anyway, we're getting far afield. We're going to take this AAC file, and we're going to roll it back out to a normal WAV file. Okay, cool. Except we're going to take this WAV file. I was interested in this. Better watch the VOD later. Yeah, I'm probably going to try to get that up on YouTube later. So we'll see how we do. So we're going to take this movie.wave that we just dumped out, and we're gonna knock it down. It's right now it's in, if we look at this thing, so this movie1.wave, it's in, this is riff is wave file standard audio, Microsoft PCM, that's our pulse coded modulation. It's in 16-bit, which is 2 bytes per sample, and it's stereo. So this is left and right, and it's at 44,100 pulses per second. So this is kind of standard CD format. We're going to knock this down to a much smaller size, just like we knocked the video down. We're going to knock the audio down. I'm going to put it into single byte format, and I'm going to throw away the stereo into a mono stream, and I'm going to readjust the samples per second down to 8,000. So this is going to be the old, this is going to sound like a telephone call back in the old days. So, right. So to do that, we're going to use SOX, which is the Swiss Army knife of audio stuff and something that FFmpeg uses. And we're going to take this wave file, and we're going to specify all those things I just said. We're going to say instead of 16 bits, 8 bits per sample. And instead of left, right, 2-channel audio, we're going to go to 1-channel audio. And instead of 44,100 samples per second, we're going to go to 8,000 samples per second. And when we do all that and we make our audio sound nice and crappy, we're going to save that as Movie One's 8 kilohertz version as a wave. Now, what's nice about that, and you'll notice SOX does that very quickly. What's nice about that is you'll see that this thing just got a lot smaller. So here was our full CD quality audio, sort of uncompressed. It was 5.1 megabytes. And when I didn't compress it, all I did was drop the quality on it. It turns into 235K. So that's already a lot less business, and it's going to sound like it, by the way. I mean, if I play this for you, and you might want to hold your ears, mute the audio or something, because this something I'll run. But this is like browser. Okay, we're going to need a little more volume there, I think. Something I'll run. But this is like browser language. And up on the server, I mean, you hear that hiss, you hear that static, and it just, it sounds bad. Okay, I think I might even be able to boost the gain over something I'll run. So this is like browser language. Yeah, it's like the crappy phone call. Up on the server, I mean, so like in a production system, we're not going to want to deliver this, but if we're packing the thing in JSON, it's a lot less bits. Okay, so that's our source material. Now, I don't have. Right now, I'd be cheating if I use the MP4 format for our video, because that's exactly what we're talking about today, is the format of packing video. So I am going to go one step further, and I am going to, and this is why we're going to get into the magic, I'm going to create an image directory, and I'm going to take this video here, this 240p video, and I'm going to extract 30 frames a second into 30 pictures. So each second will be 30 pictures, and I'm going to do that for the entire 30 seconds. So math channel, 30 times 30, I should end up with about 900 pictures. So let's take a look. I don't think it's exactly frame aligned to that, but we're going to use FFmpeg again and test. New name, new me. Sayuni. Nice name. So we're going to take that thing, which is, we're going to input, because FFmpeg, we're going to input file is going to be this 240p version. And we're going to say synchronize your video frames to make sure that you're getting a full frame whenever you drop a picture. And store that in this image directory using movie1 and image, and use a 3-digit number followed by PNG. Okay, so I do that, and it unrolls my movie, and now I got a whole bunch of images. Okay, so if I go and I look at these images, and we are going to look exactly at these images, then we'll see every single frame that we have in here. We're just going to see like, okay, here's frame 1, here's frame 2, here's frame 3, and you'll see that very little is changing, because actually I'm pausing during that part of the video. I'm talking, And so if I jump up here to like line, to the 70th image, I see that this just filled in. This little piece just sort of filled in. So if I look here, I'm drawing across at this point. So there's image 71 and here's image 72 and yep, there we go. No more mispronunciations. Nice uni. Yeah, what does the Korean say? Well, I guess we're gonna have to get an audio sample in this format. Okay. So now we have unrolled in our directory all of the images that we're going to need in PNG format. So this is something that we can read in Python, and we can quickly look at any of these images and sort of see what's going on. Yeah, please do, Siuni. Actually, if you are in the Discord, I could just mux you onto the stream, and you could tell everybody live. Or you could send a recording. It's up to you. It depends how live you want to be. Okay, so we'll play a little bit as we go. So we end up having, we have about 900 images, exactly 30 seconds of video, and we want to be able to pack those. We're not going to use this PNG format, which is cheating. That's another form of compression. We're going to turn those into just regular JSON. So the way we're going to do that is we're going to come into this file. We're going to start editing on main, and we're going to build a new route. So this is going to be the image as an array route. I'm just going to call it image A. And this, let's just return nothing, except that you're not allowed to do that because this is the image A function, and that caused my server to fail. Okay, so now I've got my nice, useless image A function, and I'm not going to need upload tonight, so we're just going to get rid of that. So let's start off by just saying, let's pick one of these images. So we can just take like image I862. All right, so we can take 70 like we took before, because I know that there's motion between 70 and 71. So let's use that. So this is going to be MIIO70 PNG, and that's going to be our file. That's the wrong directory. We don't no longer need that. That's going to be in static image. Okay, so static image, this thing. And this is going to be something that we want to load using pill. So we're going to import pilled, and I know Siuni loves when I program in Python. So actually most of the stream is going to be JavaScript, I think, or whiteboard, which Nightshade dude doesn't like when I call it a whiteboard. So we're going to take in pill, and we're going to load this image. So pill.image.open this PNG file, and that's going to give us back image 1. All right, so or in this case, image 70. So why did you change it into PNG? 715209, I didn't really specifically care that it's PNG. I just want it to be in images so that we have a single image for every frame. And I want it to be in a format that Python can read. We could turn it into BMPs, like raw bitmap if we want to read the bytes, but then we have to deal with like the header and stuff. And I'm not sure how good the pill support is for BMP, so I'm just using PNG as sort of a convenience that I know that pill can read it. Okay, so that'll load up image 70. If I print out image 70, I was doing some C before, so. If I go and hit this thing on image, oops. Oh, it's not image, it's image array. Okay, so if I go and I hit this thing, I've loaded a PNG image file, and it knows what the right size is. It knows that this is 426 by 240. So we're just going to work with single resolution tonight. We'll worry about up and down scaling later. So I'm going to take I70 and using it, I want to get this as a JSON array, right? Because I don't want to be using PNG. That'd be cheating for building our own codec. So I'm going to import numpy as numpy as np, and we're going to take I70. We're going to do np dot. What is that function? We just have to say array, right? Yeah, we're going to say like, okay, numpy array. Take this image and turn it into an array of stuff. Okay, and return that as image70 as an array. Now, I could just return that to the browser. I could JSON. It would be a normal array. I'm gonna turn it into a I'm gonna dump that image out. This is I70A. I have to call, because it's a numpy array and not a normal list in Python, I have to turn it back into a list, and then I dump that and we get a type error. Image array problem. Oh yeah, dumps. That's what I get trying to think about the naming of the variable. Okay, so there we go. There's our image in sets of 3. So that's our RG. This is like 17 RGB. And it's put that into subarrays of 3. So that each one of these corresponds to 1 pixel in the image. If I look at the image here, like if I take like image 70, of course I stopped that. So I would have to go back into here and I would have to say turn on a web server. Then I can see that, yeah, it's not that much up here. It's pretty dark. So 17, 17, 17 seems kind of reasonable for stuff up here. That's probably related to imprecision and in the original MP4, but we didn't capture raw video, unfortunately. So, well, actually, I don't have the hard drive space for it anyway. All right, so great, job done. We've taken our image and we've turned it into JSON format. No, I want to flatten this so that we don't have it in subarrays. We're just going to take the convention that you need three entries in a row to be a 1 pixel. So we're building a stupid image format in JSON. So we're going to take this thing and we're going to flatten it. And if I do that, then I get, here's my 3 values followed by the next 3 values, but they're not in subarrays anymore. So now, by the way, image-wise, I could probably throw all of these away and just turn them all into black, and the user wouldn't really care. Like, this is flat black, but I think, you know, whatever. There's some issues with this encode that we're working with in this MP4. So here's some like actual image data sort of hiding down here. All right. So great. We have a server that now takes our image, and we can forget about the MP4 from now on. We're going to build our own video format. We can now take a single frame and we can send it to the client as JSON. Okay, a little bit crazy, but bear with me. Okay, so now on the client, what do we want to do? We want to actually take this thing and turn it back into a picture. Okay, so what do we have on our web page right now? Nothing. So now we're going to go into JavaScript land, and I'm going to edit this home page. Okay, so our SUni. Okay, so SUni, who's an SSUni. Okay, good. So we're editing the right file. We are going to take this JSON that I just showed you over here, and we're going to try to turn it back into this image if we get this right. So we want to get that to show up, but we want to manipulate it directly in JavaScript. So we're going to need some JavaScript to work with. And I'm going to give myself, because we need a place to draw, we're going to need a canvas. So I'm just going to give myself, we're going to be doing raw bits. So we want to, no cheating, no using the image formats that already exist in the browser. We're going to make our own. We're making our own codec. So let's go ahead and tag this canvas and give it a width and a height. And let's stick with the 426 and 240. Now keep in mind, in this image format that I just sent down, there's no header that tells you what the width and the height is. So you have to know that you read 426 of these before you're on the next line. So SUNY. Okay, so it's SUNY. No matter what I do, you give it 3. SUNY. I'm sorry, SUNY. I don't mean it negatively, my bad. So, okay. This, so we have a nice little canvas tag here, and we should be able to load this if I remember some JavaScript. We're going to use some newer JavaScript, but not too new. Go watch Vape Juice Jordan if you want to see some of the newest. I think he's on the standards committee, so he could show you a thing or two about the latest spec. All right, so let's do a document get element by ID, and let's go grab this canvas element so that we have something to work with. All right, now just so that I don't have to keep typing out those numbers, let's just define our width as 426, and let's define our height as 240, because we're going to stay constant for the rest of this. We'll be changing the size in later episodes. Okay, so we have this, and I'm going to need a place to draw that doesn't show up on the screen. So like right now, I could just take this, and I could take this canvas, and I could go, all right, do a clear rect. Oh, sorry, I don't need the canvas. I need a context on the canvas. This is, I need to say like, I want this canvas as a 2D drawing surface that we can work with. So let's take canvas. We don't want to take canvas. We want to take the context that we just created, and we want to clear a rectangle which goes from the top left corner to the bottom right corner. All right, so we clear our canvas, and if I go and I style this thing black, background colors black, then we should be able to see our canvas in the right spot. Okay, so great, it's black, we've cleared it. We know that there's no pixels on this surface other than what we put there. All right, everything is set to 0 right now. So what do we have to do? We have to go get some JSON. Let's go fetch some JSON. Fetch this image array, and when you get it, then take it and turn it into, do some JSON parsing. And when you have the JSON parse, because everything's async, then we're going to just dump that on console. So let's just make sure that we're getting the right thing here. Okay, so if I go and I look, I don't want to view the source. We see the source over here. If I look on console, I just got an array back from the server that has all of our image data. So here's Rgb of the first pixel on the top left. Here's Rgb of the second pixel, and it's going to go left to right, top to bottom. Okay, so there's all of our raw image data. Now all we have to do is take these pixels and get them on this screen. Okay, so how do we do that? Well, let's give ourselves a function. This is our kind of getting started over here, so I'm going to move that up here. Let's make a show image array, and this is just going to draw it on the context directly. It's a little bit naughty. I should be drawing it off screen, but so image array, and that's, I've already parsed it. It was JSON, but because it's JSON, it's easy to parse into a normal array. So looking at it, I've just got a normal flat array here. Okay, well, how do I do that? I need to take this context, which I can just reach into global scope, because we're not doing proper programming right now. We're hacking around. Okay, and what I need to do is basically get the data and like manually put it back together again. So one way of doing this is I can create an image. There's a lot of ways to do this. I can directly hit the pixels themselves using the context draw calls, or I can just say, give me a new image data object, which is has a given width and a given height. And hopefully these all match. I would normally read this from an image header. And we're going to call this our image data. So this will just be image data. And now it's going to be kind of in the format. That's the format that I need it to be in to display it on the screen. So if I go and I dump this thing out, you're going to notice that this is a new kind of object that, oops, can't have my W doing that. What are you talking about, W? I'm reaching into my global scope there. Yeah, oh, right. That's, you can't do that. Let me just move this up here. All right, you know what? Let me define that up here because those are sort of pure. So if I go and do that, right, cool, we're good. This is the format of that. This is the array, you know, kind of that we got back, and you know, here's our. Oh, sorry, that's just this thing over here. So I'm going to pass that into show image array, which actually is my own function, so I can just call it because it's going to call it, and the first argument is going to be that array that we just saw. So if I go and I do that, then I see that I now have an image data object, which is, this is a typed array. This is an array buffer, if I'm using the right JavaScript language. And it's 426 by 240. Okay, but it's pretty much empty, right? So if I look at the data, there's nothing in there. Now, if I actually look at the size of this, I'd notice that this size is a little bit bigger than the size of the JSON object that I got back, which I could show you right here. Firefox will do that for me. You'll notice that the image data that I got back was, even though they're both exactly the same dimension, this is 306,720, but this thing is 408,960. The difference is that alpha value. So we have to be careful about alpha when we're packing this thing back in. There's an extra byte per pixel in JavaScript. So what we need to do is basically kind of scan across the image that came in. So let's just do it, you know. So we're gonna let I be 0 and J, which is gonna be, I'm gonna use I for row and J for column. Sorry, I for column, J for row. So, all right, so this is gonna be 0, 0, 0, 0. Yes, alpha refers to the, basically we have red, green, blue, and alpha. Now, alpha is kind of fictitious because alpha is really something that gets applied to red, green, and blue. Alpha is not a color itself. It's useful in JavaScript because I can dial it up and down to kind of fade something, but when we're talking about direct like image stuff, like it doesn't matter. Okay. So we don't want to pack alpha in when we're sending it, but when we unpack it, we're going to want to remember to put alpha there. So that's why the destination array is a little bit bigger than the source array. So we're going to start off with our count. We're just basically going to go through all the pixels and we're just going to write them over. So if they were exactly the same format, if it was RGB to RGB, I could just do let I equals 0, I is less than, you know, however long image data is. So this thing dot length, and just keep incrementing I. And I could just copy every value from one to the other. I could say, all right, take the image array sub I and write that into the I data, which it's actually I data dot data, because this has a data element to get to this thing. Sub I, and I would just assign one to the other. The problem is that this side is RGBA and this side is RGB. So I have to every three, let's see, RGB, that one, it depends if you start from 1 or 0. I have to slap in a 255 value. So I can't do this the way I have it packed right now. So yeah, let's just keep track of that. Let's just say like if, so this is kind of like I is just kind of scanning across at this point. Yeah, I'm sorry. Before I was saying that I was going to use row column. That's not what I'm going to do at all. I'm going to use J as my counter in one array, and I'm going to use I as my counter in the other array. So I is just always going to be going up. So that's my destination counter. So I'm going to say every time the destination counter mod 4, so divide it by 4, look at the remainder, is equal to 3. So when I'm on the last one before it goes back to 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, then that time I'm going to ignore my source image, and I'm just going to say you get 255, okay, because that's the alpha value. Otherwise, just copy the red, green, and blue. So this is the red, green, blue. This is the alpha value. Okay, so if I do that, I should move from one to the other. We should be okay. These values are all byte. Each one is a byte, so it's 0 to 255. So I'm staying within the uint8 clamped array size, and that's fine. So we do that, and we look at the image data again. So I'm just going to take this thing, and it was all zeros before. We drop it out down here, and now there should be a whole bunch of stuff in it. We have, so in my source array I had 17, 17, 17. That turned into 17, 17, 17, 255. There's our alpha value. Then 888, which turned into 88. Uh-oh. So I didn't quite get my array right here. So this is, because I'm not incrementing j. So this is, okay, so really I want to copy the j value, and every time I copy a j value, add 1 to it. All right, so j is basically my counter in the source data, which is image array. And I is my counter in the I data, which is my destination array. So if I do that, this is why we debug and test. Okay, j is not defined because I deleted it before when I was showing you. We're going to say j is equal to 0, but we're not going to increment j over here. Cool. Then that means 17, 17, 17, 255, 888, 255, 888, 999, 255, 999, 666, 255. Okay, so we did our copy, except we threw in this 255 for the alpha every time. Okay, hopefully that made sense. A little bit confusing, but just moving from RGB to RGBA. Okay, what would the image look like if you did it like that? If you did it like that, if you just did RGB, then basically it would interpret every fourth value as the alpha, even though it's actually the next red value. And then it becomes, be off by 1, then it'd be off by 2, then it would be off by 3. So it would look wrong. I mean, it'd be a different image from what we sent. And alpha, if it's not 255, it darkens that bit. So no matter what you put into these RGB values, it would darken it. I'll show you that. Let's do that. So right now we're just dumping it on console, but this is not the proper way to be looking at an image. We don't look at images on console. We go and look at them as images. We're human beings. Uni is a human being, I believe. So we're not going to console log this thing anymore. We're going to take our context that we had before, and we're going to put image data in there. We're just going to say, take this image data from this iData that I created and write it in the top left corner. Wow, look at that. Man, if you all saw the prep session, it was not like this. Let me tell you, not like this. That's that line in the Matrix. Okay, so yes, I'm blown away here, 715209. So this, what would it look like if I didn't have the alpha value? And this is actually when I first built this, I did not have alpha correct. So I was actually just writing 0 in for the alpha value. Everything's black. It doesn't matter what data comes back. It all shows up as black because the alpha value is 0. So it's saying darken this pixel entirely, no matter what its color is. We want it to be 255. If we go and we do that, then we get the image at full color. Now, if I take it at halfway, like 127, then you'll notice that it gets a little bit darker. It's dimming it. That's what happens if you play with the alpha value. So if you write red, green, and blue values into the alpha value, it's going to look like crap. So this is a nice way to do fade in, fade out. I mean, it has uses, but it's not useful in the sense that I could pre-compute the alpha in the RGB. So I don't need to transfer it. I'm worried about how many bytes I'm sending to the browser. I know this is JSON, but eventually we're going to be worried about how many bytes we're sending to the browser. I mean, it matters because it's going to affect how fast the playtime starts. We're building a streaming service. We care how long it takes. Okay, So and you can watch the first episode if you want to see about the iron triangle of streaming. So Anthony Park's innovation, which I really like. Okay, so we know how to take an image from JSON, which looked like this, and we know how to turn it into this so that it looks exactly like the image it said. If I change the image, like if I make this like 75, so you see that this line is mostly formed, then all we need to do is come down here and pass back image 75. Boom. We get our line completed. Okay, so we know that this is working. Cool. Let's make that a parameter. Let's extract that thing and just say pass along an image ID. Is it missing the bottom right logo? Is it? Oh my God, it is. All right, so we actually, oh, that's, yeah. We're gonna have to get back to that. I'm gonna need a better image which has more data because I have a feeling I might be cutting it, but we'll worry about that a little bit later. That could have happened in decompression. We'd have to dig a little bit more to figure that out, but we'll come back to that. So let's worry about this line. And by the way, good eye, 715209. If I could award you points, I would. we're gonna need to add that to the bot. Okay, so let's take in an image ID parameter so that we're gonna specify like which image we want. And instead of taking always image 75, let's take this thing. We'll mix in the number here, make sure that it's 3 digits, even if we pass in less. But let's also just for safety, let's ensure that this thing is an integer. So this will cause it to throw in the event that it's not, but it'll also convert it to an integer. I know you shouldn't overwrite the variable. We're hacking. Okay, so we get a, oh right, it's no longer called image A on the source. So this is now called image A and then whatever frame we want. So if we want frame 75, oh, wait, what? Oh, so I'm actually getting an error here. Oh, image A 75, file not found. Oh, yeah, well, it's because I need to pad it. So it's not 03, it's 03. Yeah, there you go. Okay, so now I get the right image, and if I load it here, yeah, okay, cool, we get the right thing. So now on the client side, we can specify which frame we want, which is cool, right? I can say I want frame 78. Okay, 78, let's take frame 120. Yeah, there's starting to be this B over here. Let's go far in the future. Let's go to frame 700. Okay, so this is working and something going wrong down here, as 715209 pointed out. Okay, cool. So now we can directly manipulate the image surface. I don't know if you've worked with Canvas before, but that's kind of the nuts and bolts of how you can directly write the image based on this JSON data. So we didn't talk about images. We talked about video, and video is about lots of images. So we want these images to be kind of cycling. You know, we want to be rolling through and showing these fast enough that our eyes are tricked into thinking that this is a regular video, and you know, it's not really just a bunch of images that are being shown. So now this source that we're working with, we know that it's 30 frames a second. So basically what I need to do is fetch this thing. I'm going to go like the slow way, which is we're just going to fetch this thing 30 frames a second. Okay, so we can get there by just center-leveling, and let's build ourselves a little mini function that does this. I'm going to remember to return a variable, so we're going to const this thing. This will be our video timer, and there's my one line that's going to be in my function. And I know this code is a bit sloppy, and we're going to say do this. I'm going to slow it way down, so let's do 1 per second. Okay, now right now it's just going to keep requesting the same frame over and over, which is not what I want. So let's count. Let's have a variable called I. Sorry about these I's and stuff, but old habits. And we're going to use new style syntax because I don't want to mix this thing in. And we're going to say put I in right here. So it should be requesting 1 image a second forever. So that's eventually going to overflow and run out of images. But okay, so this is, oh, it's starting from 0, which we don't want to do. We want to start from 1. And we also want to remember to increment I each time we do this. Okay. Okay. That looks like it's working. So we haven't seen the image change because I think in the first part of this video we don't really do much, but we know that there's some action happening by frame 70. So let's jump over there. Yeah. There we go. We have crappy video. So, and you're right, 7152, and I see there's 2 points. 2 points, dude. Okay. So this is now playing really crappy video. I wouldn't call it video. It's really just changing this slow enough that we don't see it. So let's pull that console log out and let's speed it up. Let's go every half a second. Yeah, it's starting to get a little smoother, right? Starting to look like a video. Okay, now let's keep going. Let's start this all the way at the beginning. And now, who here knows what 30 frames a second is? In terms of milliseconds. How many milliseconds is each frame if it's 30 frames a second? Good guess. Yes, that's barely qualified. That is exactly correct. So yeah, we can actually calculate it. So and that is the right thing to do because we are this parameter here is in milliseconds for the set interval. So if we take 1,000 milliseconds, which would be 1 second, we divide it by 30 frames that have to happen in a second, we would get how long each frame is supposed to take. Now, I'm not doing any preloading here, so we're allowing network time. We'll get fancier later, but let's start there. All right. Now, when I do that, it suddenly turns into regular looking video. That's it, everybody. Job done. This is amazing. Here we go. We just rolled our own video codec. Not bad. Now, you'll notice we're getting a little bit of flicker. I don't know how much that's going to come through on the stream. And I'm seeing a little bit of flicker. And the reason for that is we're drawing directly on this canvas context. Oh, so there we go. We ran out of frames and it starts erroring out. So we're going to need to cap it at 900. So we're going to have to say something like if I is greater than or equal to 900, then clear timer, clear interval of video timer. So I'm going to take advantage of the closure. All right, so we do that and it should be fine. So in 30 seconds, we'll know. But next thing I'm going to want to do is I want to smooth that out. I don't want to draw directly on the surface because drawing directly on the surface means that I'm racing the beam. So I'm drawing on it, but I'm also the computer's scanning on it, and that's sort of bad. So the typical game pattern for this, video uses it too, is you don't draw directly there, you draw onto another surface, and then you swap the surface. Okay, so in the case of the browser, we don't have to directly worry about swapping the surface. All we're going to do is just basically tell it to copy it, which we'll let the browser figure out how to handle that under the hood. I'm not even sure if that's exposed in normal 2D contexts. I'd have to go do some research on that. But so by the way, this 1,000 divided by 30, we're just going to unroll it because it's actually going to turn into a fraction. It turns out that it's about 33. If I do that here, 1,000 divided by 30, then I get 33 point all this stuff. So we're going to call this 33 milliseconds. There's some JavaScript time. It's not quite exact. Now notice that time I didn't get any errors, so it's stopping. Cool. So we are clearing our interval, and that's neat. Let's just move this over so we know that that's inside our function. And cool. Well, how do I draw this thing somewhere else? Well, right now I'm drawing directly on the canvas. Let's not do that. So let's draw, we could draw on another canvas and move it off the screen, which we have in JavaScript. It's called an off-screen canvas. What do you know? So we can actually just initialize an off-screen canvas directly. This is something. This is. I think this is relatively new to the standard. I'm not sure exactly when it was added. That'd be a good question for Vape. But so we can basically just new one of these things up. We can say like, and it won't actually bother to put the thing in the DOM because it doesn't make sense to put the thing in the DOM because it's never going to be drawn on the screen. So it'll just give me the memory and the data structure, and I can go manipulate the bits, and then I can just swap it on. So that'll get rid of some of that video tear. So let's go and do that. We need it to be the same size, the width and the height. This we can use later for scaling because we could actually put this thing one size, and then when we copy to the canvas, we can make the canvas a different size, and JavaScript will take care of scaling it for us. So we don't have to do the bit manipulation for that, which would be another class. So, but anyway, let's call this the off canvas, and the off canvas we're gonna need an off context as well. So let's take a we're going to need to get using exactly the same trick that we have with the off canvas with the regular canvas. We're going to say get context 2D and store that in our off context. Okay, so we still have a surface that we can draw on, and we can clear this, and we can clear the off context as well. All right, so we run that. Should get no errors. Yeah, our video's playing, whatever. So instead of showing the image array directly on the context, I'm now going to draw it onto the off context. And off context is going to have this create image data, and it's going to put the image data on the context at the end. So I think that'll handle the copy for me. So there you go. So done. So all right, bugs aside, I think that's the right pattern. Yeah, at the end I basically just say put image data, and I take this image data, which was actually drawn on a different context, and it throws it straight on the context, which is attached to that canvas. Has this technique been used in the past? 75209, I'm not really sure. It's definitely been used at lower levels than browser and JavaScript. I mean, like this is basically how bits end up on the screen. I mean, modern days, this is actually implemented in a chip. So there's a decoder chip, typically in hardware, that you could pass it the image, the movie format directly. But we're actually building a software decoder, sort of like in the old days. And yes, it used to be just directly managing the RGB like we are. Nobody would actually pack it in JSON. Because that's a lot of overhead for no reason. I mean, there's no reason to parse this, but okay. So how does the off canvas make it clear? Is it choosing only to re-render pixels that change, or sorry, I didn't follow. Good question, barely qualified. So that's a great nickname, by the way. So the way that works is basically we're going to create the image that we're going to be drawing on the off context, which is the off-screen canvas. So now we have an off-screen canvas which is not in the DOM, so it doesn't participate in the DOM. On that, we're getting an off-screen context that we can draw on the canvas. This is just sort of a webism. So I have this off-screen context that I can create an image on. That's not attached to the screen. I then do my image stuff, which is based on this iData, which is now sitting on the off-screen context, and I draw the whole thing down, and when I'm done with it, I basically just copy it all over. So now there's no drawing while it's drawing, so if the browser's refreshing the screen, I'm no longer racing the beam, so I don't get that visual tearing. This is called double buffering. It's a little bit weird euphemistically in JavaScript because there isn't actually a buffer.swap, which would be how this is implemented in C or C++. You like an SDL on an SDL surface, you would actually just say like, swap. You would say you're pointing to this memory address for video for the image right now, point to this memory address, which is the off-screen context equivalent here. And then all it does is just update that. And then the video memory basically just starts drawing the bytes directly from that location on. So that's what removes the tearing, because you're no longer drawing while the video hardware is drawing it on the screen. Let me know if that made sense. It's a little bit complicated, but basically the idea is that you draw it somewhere else, you get your image right, and then you just quickly move it, and you kind of keep switching between the two. Yeah, that's exactly what it is. This is called double buffering, actually, 715209. That's exactly what it is. It is. We're drawing into it as a buffer, and then we're saying, okay, display this. And then we're drawing into the next one, and we're saying, okay, display that. Okay, and then we're drawing into the next one, and we're saying, okay, display that. Now, in this case, I'm always drawing into because it's JavaScript, I'm always drawing off the screen and copying it over. And I'm drawing off the screen and copying it, and so we're leaving that up to the browser. But basically, it makes it so that the video hardware isn't racing against the image decode and the me padding out the RGBA each line. Cool. We have video. That's great. So we have two things we can do here. We can get into Delta, because Delta is basically, this is right now we're downloading an entire image for every image, but most of those images are not that different from each other. They're actually just like, as I'm drawing on this board, it's like just this line moving along and, this other stuff. So I can create the delta and just apply the delta. I can take the image and just keep slapping the delta on top of it until I get, smooth video, and then show that. And that's a little bit more CPU intensive, which is why I definitely want to be doing it off the screen. Or we can jump over to audio. So I don't know, which one do you want to see or hear? Barely qualified, because you can't tell the browser when to re-render really. So you do the math first for the whole frame and then tell it to render rather than letting it possibly re-render halfway through. That's exactly it. Barely qualified. That's a great nickname. I love it. A lot of talking. I got a drink. Okay. Just water tonight. This is a little too complicated to be having anything else. Okay. So we have video. Let's play with some Delta stuff. Yeah, I really want to see both as well, Brandon. Let's see how far we can get. Okay, I mean, this is already it's not an hour session. I mean, none of these sessions are really going to be just an hour, but okay. So let's start with Delta. It's really nice. This is part of why I'm picking Python, which Siuni loves, and that's mainly because I get to use the NumPy library. I also get to use the pill image library, so I get quite a lot for me. Now, again, there's stuff in NPM I could get to do equivalent, so it's not like this is a language one's better than the other, but it is really easy to do this type of numerical manipulation in Python, and that's part of the reason Python is really common for data science. So this is where it's going to really be useful. So, by the way, where can I find your YouTube? I think the bot is online tonight. Let's. Oh, of course the bot's not listening. Bot, what are you doing? I got to give it the right command. There you go. That's where you can find the YouTube. Cool. I'm not used to having the bot in stream. That's kind of neat. Oh, and of course I left a bug in there, but okay. So these are all going to end up, the CSGFlix is going to end up on YouTube. So I think it's a little tough to follow some of this stuff on Twitch, but live, but hey, we'll keep rolling. We'll figure this out. Okay. So we have this image thing. What we really want to do is build another version of this that does deltas. So we want to do image array, delta, image array D, imgad. All right, so we're going to call this imgad. Okay, now it's funny that this is still called I-70 because that's totally wrong, isn't it? It's no longer I-70. This is image 1. just the first image we're going to work with. This is image 1 array. This is image 1. I'm going to fix this real fast because I'm about to get burned as I copy pasta it. Okay, so that is going to cause my program to fail. We're going to go to image get, and that's going to be image get. Okay, that thing, and that should work. I'm probably going to have to restart this thing. Yeah, okay, we're cool. So if we go and look at this, we didn't break anything. And if we look at image get, we're getting, right now we're getting exactly the same thing. Okay, so let's do a delta. So basically we have all of this stuff, and we're going to have 2 images now. We're going to have, like, say 75. And so for simplicity, I'm just going to assume that we're going to do the delta from the first image for every one of these. So no matter what you request, I'm just going to say, take image 1, take whatever image is specified, and calculate the difference between these two. Now, that's not really needed for an optimal video encoder. We really only need the delta from the previous frame. But for now, just because I don't want to deal with more parameter parsing, we're just going to assume that we're always going to take image 1 as image 1. So in this case, I'm going to take image 1, not as this. It's actually going to be really image 1. Now, that'll show me the array for image 1. Yes, it does. Okay, cool. We don't know that because this part's the same anyway, but we can see here that it's loading image 1. All right, cool. Now we need image 2. And image 2, which is really going to be, our difference is going to be the difference between these two. We're going to say image 2 is whatever was passed in. So image 1 is always going to be the first image from our video. Image 2 is going to be whatever this URL parameter is. So if it's 75, I'm going to get the 75th image. Okay, I run that. There shouldn't really be any error there because I'm not doing anything with image 2 yet. Now, what I'd like to do is say image 1, and I'd subtract image 2 from, well, actually, image 2 is in the future. So I could say, well, if I want to recompose it, I could say my delta image is really like image 1 minus image 2, except the problem is that that's destructive. So if I subtract all of those array elements from each other, I might lose some information. Like if I say like this thing minus that thing, then I don't actually want a subtract, because what I'm going to end up doing is I want something that works whether it's subtracting, adding, or whatever. And it turns out I have a logical operation that does exactly that. And that is XOR. And in that case, I want to basically say if the bit is in one or the other, send it through, but not both. Because if it's in both, I don't want to reapply it on the other side. Like if it's already there. So I'd be wasting bits that I'm sending, basically. Like, so if just super quick review for those of you who haven't looked at logic in a little while, truth table. So this is like image 1, and this is image 2, and this is the result. Here's my truth table. This thing is true, true, false. Wow, that was a terrible F. Let's try that again. True, true, false, false, true, false, true, false. Okay, so these are all my cases. Both are true. One's true, the other's false. One's false, the other's true. One's false, the other's false. And for an XOR, which is really I1, there I go, sloppifying, I1 XOR I2, that's going to be, when they're both true, it's false. When one or the other is true, it's true. And when they're both false, it's false. Okay, so this is neat because if image 1 has a pixel, like if this T is like a pixel is on, and image 2, the same pixel's on, I'm not going to send anything, right? I'm going to end up basically saying, yeah, just send a 0 for that. And if one or the other changes, worry about it. But otherwise, don't. Okay, so I end up with my XOR operation. And let's go back here. There is an XOR image option in JavaScript. I had a lot of trouble working with it, so we're just going to manually do it. we've already built our little pixel blitter anyway. So we're going to do XOR. And that's going to create our delta image. Now, the delta image is, except in order to be able to do that, I need to be working with arrays. So I'm going to not flatten this thing anymore. I'm going to move this over here. Image 1 is going to get turned into an array, and image 2 is going to get turned into an array. Okay, so I've got the image 1, I open it up, I turn it into a NumPy array. Image 2, I open it up, I turn it into a NumPy array. And now I'm going to say, take image 1 array, NumPy array, XOR it with image 2 NumPy array, that's your delta. Okay, so if I do that, that's important because we're going to have a lot of bit values in these RGBs, then send that thing back. So this is really delta I, turn it back into a list. Okay, most of the image doesn't change. Look at that. Big surprise. Now this is cool because we're only seeing the XOR of the two. So we're only seeing the places where the bits changed. And that's cool. I think it's cool. I love that how little code it is to do because of Python. Thank you. So try to do this in JavaScript. And always like counting and stuff. Okay, so coarse language. All right, so we're going to take this thing and we're going to flatten it because right now we're just listing it. But let's flatten it first because right now we still have these RGB values as a subarray. So we're going to turn that back into a flattened array. I do this. Cool. There we go. Now we get rid of all those subarrays and we're just left with RGB values for the stuff that's flipped. All right. So if I try to just display that as a straight image, and to do so, we're going to go back over here. And we're going to go back over here. I'm going to reuse that same context. So let's comment all this stuff out that we just spent so much work putting together. And let's basically take this line here, but we're gonna work with it a little bit. So let's take, this is image A right now. We're gonna turn it into image A delta, and we want to take the delta all the way up. Let's take like 70. So this would be the delta from image 1 all the way to image 70. Okay, now instead of showing it, I'm going to just dump it on console to get started, except that's going to end up bind things. We're going to say x is, it's a function that says console log of x. Okay, cool. Do that, and we should end up with our values. So if I jump down here somewhere deeper in the array, some of these values should not be 0, but I don't know, I could be hunting all day. This is actually really good for compression because all of these zeros, we can run length encode them. Okay, yeah, so here's some stuff that actually changed down here in 37,000. So these values are just bits that are going to be different. So if I take the image, if I take image 1 and I apply this to it, I should end up with image 70. But the nice thing about this, it's very compressible because the majority of what I'm sending in the delta is zeros. So I can actually display the delta itself. So why don't we just do that first? So let's go back into our, I hate to change it because it's already working. All right, let's just copy it. We're copy pasta. Okay, so show image array delta. Naming is hard, so I'm just gonna be unimaginative. So we show image array delta, and that's going to take the image array. We're going to use our off-screen context. We're going to do our same RGB A to RGB unwind. That's our blit, and we're going to drop it onto the context so that we can see it. Okay, so let's image add. Now this thing does take an IID, so it's going to be this one. So this should be the delta between image 1 and image 70. Wow. Worked first try. I can't believe that. That calls for a drink, even if it's water. I think that's a big deal. I'm I'm very happy about that. If I take this thing and I go all the way to the last image in the series, like image 900, I've drawn the entire image. So here's the part. Now, this coloring stuff, this is really related to digital noise. These are compression artifacts. So I can actually see exactly where like the frame is changing and it shouldn't be changing. Those should have just stayed black, but that was before, like when it noticed that some of this black wasn't really black. You know, there's some video compression, it did some, threw away some bits, but that's what this color stuff is. But you can see the main stuff is here. So aside from a little bit of digital noise, this is actually the delta. So this is the delta all the way to the end. So if I apply this delta to the beginning, I should get the last frame of the image. So this frame really has just what's changed. If I start from what was already there and I apply the XOR on top of it, I should end up with the last frame exactly. Okay, so let's roll the dice. I mean, literally. Oh, 10. Actually, that's binary. That's a really good roll. I like that. I mean, if you want to see that, I'm gonna show you the hardware cam. This is our 10. So 1-0. I really like that. That's neat. I rolled the only thing that's binary on this die. Okay, cool. So great. Let's go do this. We'll show image delta. Right now we're actually just showing the delta itself, but we're not applying it to the original image. So to do that, we're going to need two pieces of information. Right now we're just fetching the delta, but we're going to have had to have known the original image to be able to apply the delta to it. So let's just do that, which is pretty similar to what we were already doing, except we're not going to do the image delta. We're just going to say, give me image 1. And if I can just reuse this routine because the delta part is actually happening on the server at the moment. It's not happening on the client. Okay, so this'll make sure that I have an image array which corresponds to the first image. So now we're going to expand this function for what we're going to do. In this case, this is going to be image 1. I'm going to be a little more careful about naming at this point. And inside that, we're going to run another fetch where we're going to try and fetch the last frame of this thing. And we're going to say, okay, take the last frame, which, yeah, that's okay. This X is only contained in here. And it's going to call show image delta with the value that's come back, which is really X. But I don't need to do that. I need to do it with both of them. So since I want to apply both of them, I'm actually going to turn this is going to be Y. I'm just going to call it Y now, which is actually, let's call it image 2. So this is the delta part. So image 2 delta. And call show image array delta with image 1 and image 2 delta. Okay, so what I want is I want this thing to start with image 1 on the canvas and then apply the delta on top of it. Oh, hey, what's up, F2O? How you doing? Wouldn't 1, 10, and 11 be binary options on D20? Points to F2O. You are absolutely right. I misspoke earlier, but I guess I was just so excited that I rolled some binary on a D20. So apologies, but that is absolutely correct. Okay, so now I've got image array, which is really image 1, and I've got image array of the delta. I'm going to spell them out here. So this thing is really image array of image 1, and iData is a local, so that's all fine. And that's going to show up. So that'll actually work. I'm just, at the moment, I'm not using image array delta. Okay, so we run that, and we get an error. So image array is not defined because on line 41, we're using image array, which is image array I1. Okay, run that. Okay, so it's showing image array 1. This is the first image, image 1. Now what I want to do is I want to reapply that delta to it. So instead of just showing the byte directly, I'm going to XOR it again. And I'm going to say, and again, I don't have to worry about the alpha components. We don't care. But we know that we're at exactly the same offset here because I haven't moved J forward yet, because I'm going to move J forward on this line. Okay, so I run that. There it is, the last frame of the video. Now that I composited by taking the first image in the entire sequence and XORing the last, the delta, just the delta. And it worked. So, sweet. That's totally magic. I love it. Okay. So just for reference, for those of you who are curious, I'm going to put that image under this context. So right now I've got my canvas here. So why don't under it, we're just going to throw a few BRs because sloppy web programming. And let's load the image for, we'll load it directly. So right now we're coming through the Python processor to get this JSON formatted thing, but we could actually just hit static movie one image 900.png. Okay, except except that's in the image subdirectory. That was a pretty good guess. Yeah, okay. So this is actually image 900, but this is actually the composition. So let's take a look at the delta of that, and which I don't have in image format, do I? I have it in JSON image format. So I'd need another canvas to do that, but I kind of want to see it. So let's play a little bit. That was working well, so hey, why not? We're going to call this delta canvas, and we're going to take delta canvas, which is going to be an on-screen canvas like this one, and I'm going to show, when it does this show image array delta, I have the delta handy. Yeah, that's a bummer, isn't it? So what I could do instead is pass the, use this context. Okay, so if I do that and I say use this context, and down here where I just commented out, I fix that, and now I would have to actually turn this into a function, which I don't need to use that notation, sorry. I could just say like x pass along show image array, but now it's going to be the normal context with x. Okay, so that should repair that, but now I can reuse it because in this dude over here, I can call it with a different context. So I can say let's collect our canvas grabber again, and let's put this here as our other canvas. What did I call it? I call it the delta canvas, which actually sounds a lot cooler. The delta canvas was referred to as delta canvas. Okay, so it's called delta canvas. So that, sorry, this, I want to grab the element for the delta canvas, and from the delta canvas, I want to get the delta context. I'll spell it out a little bit more, and let's go and show that. So now I should be able to do show image array of delta context and image array delta. All right, so we roll the die again. Hey, all right. So this is the delta that we're downloading, and we are getting the first image, and we're applying it, and we end up with that. Cool. Brandon, I'm with you. Let's not jinx it. Let's keep going. Let's just keep going. I feel like this is good. I feel like this is not. I should quit while I'm ahead. Maybe I shouldn't quit while I'm ahead. Whatever. You're all here. You're hanging out. Should we go a little bit more? I mean, you know, the real role here is we try for audio too. I think in order to do that, I'm going to have to arm myself with the power glove. Let's do it. we have the power. Let's go for the audio. We're done with video. Well, this video's working. We got this JSON encoded custom codec, and it's nice and compressible because in this delta format, we have large runs of zeros. We can just take all those zeros and run length encode them, which is totally something we're going to do in the next class. We could roll the D20. No, I'm feeling. I put the power glove on. We're doing it. I think F12. We're doing it. Hell or high water. As long as I can say SUNY right, we're going to do it. Did I say SUNY right? I don't know if SUNY's still here. But I did appreciate SS Uni spelling out SUNY phonetically for me. Thank you, SUNY. So, great. We're going to leave all that image stuff alone. We have delta images. We have regular images. We have video frames. We're missing audio. So let's give ourselves some audio. How do we give ourselves some audio? Well, we start out with a route. Okay, so first step, just like we did with the video image, is we took our, we're going to add an audio route at this point. And our audio route, audio array, I guess I could call it AA. That's going to be a, no, we're just going to pass the entire file back. We're not going to worry about chunking or individual frames or anything like that. So AA, totally. Yeah. Woo. Don't want to pick on those people. So this is just going to return nothing at the moment. And let's take a look at that. So that's our static. Let's go to our audio data. So right now that's our web page, and our audio data is currently, oh, wow, sorry. Go back there, browser. Okay, our audio data is currently empty. All right, I'm gonna close some of this. So we have our audio data. Actually, we have nothing. We begin with nothing. We're thrown into the programming world with nothing, but we will make something. Okay, so in order to do this, we're gonna import the default wave library, which is built into Python. Thank you, Python. And sorry, SUNY. And we're gonna basically, wave follows standard Python semantics for files, so it's open just the same as like normal file opens. I'm really impressed we got this far. All right, no, I knew we were gonna do that. So what are we gonna open for our wave? Well, we wanna take our nice crappy audio, which as you may recall from earlier, sounded like, and I'm gonna boost the volume again, this.
Yeah, something I'll run. So this is like browser language. And up on the server, just because I want to try to keep things simple, it'll probably be a bit of Python.
Oh, sorry about that. I overdid it. I won't use 300. My bad. Got a little bit excited. Okay, so all right. So what do we have to do? We have to open up this audio file, which is in static and movie 1 8 kilohertz wave. All right, so static movie 1 8 kilohertz wave. All right, so we open that thing. Nothing should happen, yeah, because I'm not actually doing anything with the data yet. So I'm going to be nice and Pythonic and say with this thing as f, do something, which we're going to end up having to do. And now I have a way to get audio data. Now, Wave gives you a bunch of nice features off the bat, including read frames, which basically is going to read every single frame that's in this file. So keep in mind, in audio pulse-coded modulation, I'm looking at pulses and how high that pulse is at each instant. How many instants per second, sort of like we had our frames per second, we have our samples per second here. That's our sample rate, which this file is 8 kilohertz. So we have 8,000 samples every second. So question for the audience, chat, let me know, how many milliseconds apart is each sample? And while you're working on that, I'll work on this. I'm going to read frames, and this is basically specify how many frames. I need some math. Come on, people. Give me some math. And if you're not in the mood for math, don't worry. I'll do the math for you. So this is just going to be, we're going to call this our audio data. We can actually call it audio data, and we can be Pythonic about it too. So, because we're in Python. So this will read one frame of audio data. And if I print that frame out, it's going to be very boring, but I can come over here, reload this, and there's my binary data. That's the first frame. Now, if I read 5 of these frames, 10 of these frames, actually 8,000 of these frames, that would be 1 second of audio. Error, math not found. Nice. There you go. This is 1 second of audio from that really loud sample. Sorry about your ears. But that would be the equivalent of 8,000 bytes. Now, this is in binary hex representation in Python. So this is /x. That's not really in the data, the \x. That's just escaping. This 80 is hex that's in there. So it's 80, 80, 80, 7F, 80, 80, 81, all this stuff. Now, this, just to let you know, is in unsigned format because 8-bit audio, according to waves, must always be in unsigned format. Now, you're going to see a little bit of wave perturbation around these things. Why is most of it 80? That's because 80 corresponds to 128, which out of 256 is exactly in the middle. So they didn't have signed math. They didn't have a standard on signed math in the wave format at the time. So it was added a little bit later. So 128 corresponds to 0. 255 corresponds to a 1 in terms of like full pulse, and 0 corresponds to -1. And JavaScript, of course, is going to use that -1 to 1 range. It's float 32 array. So, but this audio file that we have in character in single byte format is unsigned. So I'm going to have to remember to subtract 128 to get it to be between -128 and 128, and then I'm going to have to divide by 128 to get it on the range from 1 to -1. And I don't know why I had to do that with my hands when I have a perfectly good whiteboard over here. 0.125, I don't know. Let's check your math. I'm not really sure. I was asking the question, but I didn't really know the answer to it. So the question was 8,000 hertz, which is 8,000 samples per second. So if I want to do that in, it's 1 divided by 8,000, which is, so in milliseconds, that would be, which is probably what Brandon is responding, 0.12. All right, so close. But actually, I think you're probably right, Brandon, because I think I only did 5 digits of precision. Yeah, I only did 5 digits of precision. So let's bump that up and see if Brandon's totally right, because I have a feeling Brandon is. Yeah, it is 125. If I multiply that out to from seconds to milliseconds, I get 0.125. You are absolutely correct. What are the tildes? That's the tildes that you saw there, 715209. They're not really tildes. It just turns out that those hex digits are printable, so Python prints them. They're not really tildes. It's whatever the ASCII value is. This will actually make a little bit more sense if we don't look at it with hex escaping, or if we look at it fully with hex. Like let's say we actually look at the hex. I don't know if I should be showing this on a JavaScript stream, but what the hell? You live once. Okay, so this is actually a hex dump of the raw wave file that I just was playing around with. And there's a little bit of magic stuff up here. This is the header, right? And that's riff means that this is a wave file. It's in wave format. It's riff formatted audio. And there's a bunch of stuff describing how many channels there are, how many samples per second, all that stuff. That's our header. And then down here, we have our actual audio data. And you'll notice that most of it's at 80, which is 0. And there's no tildes. You'll see here, if you saw tildes, they'd be over here on the right. So that's ASCII representation of stuff that's happening over here. So in this case, this is your tilde. And I think if we look at an ASCII table and we look for our tilde, then we're going to see that it's down there. Yeah, it's okay. So that's it right there. It's 7E. So if I look for 7Es, yeah, I have a 7E on the 1, 2, 3, or 0, 1, 2 on the third byte on this line, and there's on the third byte of the line, there's a tilde. So it's not really a tilde, that's just ASCII representation of some hex. Okay, I'm gonna have to convert that back, but that's basically, this is the hex. This is the raw hex. But because we're in Python, we're not going to want to look at raw hex because we can work with numbers because it's Python. Hey. All right. How many frames do we want to read? We don't want to read just a second of audio data. Let's read the entire file. And it turns out that you can actually query this thing and say how many frames are in the file. It's going to read that header that I just showed you over here. I shouldn't point. So in this header is actually some information about how many frames are in this file. And I can access that by calling get the number of frames that are in this file. It'll read the header and tell you. So if I read in the number of frames and I say read frames, as many frames as in the file, the audio data will now be filled with all of the audio data. All right, so I go and I run this program. And now I get all the audio data, not just a second of the data. And I take that thing and I can start getting crafty. Crafty's fun. So we can take that and convert it into, we don't have to deal with it in hex. We can actually just treat it as numbers because Python. So I can just take this thing and say, turn it into a normal Python list. And all right, I can't run this program. I have to hit it on the web page. And it actually turns those, it takes the hex and it turns them into normal numbers. So I can look at them as normal, ordinary decimal numbers that we're used to seeing. Cool. Point to the header on your screen. SUNY, for you, I will do it. That's me pointing to the header. That's it over there. But if I was going to point to it on the screen, I could actually just select it. So this part up to, well, actually, see, I clipped off the top line. So let me take that from here. This part up to here is all header. So I could actually parse that header if we wanted to write our own wave parser, but Python has a perfectly good wave file parser, so I'm just going to use it because why write your own for that? Nice elbow, 6 out of 10. Sorry, SUNY. I'm losing points with SUNY. You should get something to draw everywhere. I totally should. 715209. All right, you know what? Just for you. Oh, you know what? That's totally not going to work, is it? Ooh, that's not the thing that I wanted to hit, is it? Yeah, you know what? Sorry. I broke my streaming tool a long time ago, so we can't have that. We can't have nice things. Okay, so let me just pull that file back up. And we're good to go. Okay, so we have our stuff. And okay, so this is JavaScript. We're down here in Python land. And we've pulled the thing in, we've pulled all the audio frames in, we've turned them into normal numbers, we know how to work with them. Now we could convert them in Python, but that's not really the point of this. We sort of want to do the unpacking of this file in JavaScript, sort of like I did before. So let's not print the list out here. Let's actually send it all the way down to the client. How do we do that? Well, since I have a with, I have to, use a kind of standard pattern. This is going to be JSON, so I'm going to do, actually, you know what? We're going to do this. So actually, this is going to be an array. And let's return JSON.dumps result. So right now, that's going to return an empty array. Cool. And if I go and not print this out, but set this to result, is now going to be this thing. All right, I get my audio data in the browser, which is kind of where we want it. Now, it's in normal numeric format, so I don't have to worry about changing it from hexadecimal or not, but I do have to worry about converting it to the right audio format for the browser, which I'm going to have to take this unsigned thing, and I'm going to have to put it into a float 32, which is how the browser wants the audio data to be. So that's web standards. Talk to Vape Juice Jordan if you want to know why. I don't know. I guess it's the most neutral thing they could do was to use a float 32. They already had a float 32 array, so this is the float 32 array that we're going to be using. We could new one of these up and basically construct the whole thing from scratch. Say we're going to need this thing to be 8,000 long. That would be 1 second. So, and it'll give me lots of zeros. Now this is going to be where my audio data is stored, except these numbers need to be from -1 to 1, not from -128 to +128, or in the case of this, 0 to 256. So we're going to transform them back. Great. How do we do that? Well, we go back to JavaScript and we stop playing around with images, right? No more of this image nonsense. This image voodoo. We're done with images. So if we reload this thing, it should be black. Okay, you're black. Let's deal with some audio stuff. So how do we begin working with audio stuff in JavaScript? Well, we could use the audio tag, but again, that's downloading, that's not streaming. I want to be able to manage bytes directly. I want to be uncompressing on the fly, and I want to be playing, and I want to make sure that I'm synchronizing with the video. So let's do that. I'm going to whip up a new function. We're going to call this do the audio. Do the audio. All right, and doing the audio is going to wrap my audio stuff, so we're just going to call do the audio down here. So we don't put everything in one spot. And let's take this thing. Now, in order to do this, the first thing we're going to have to do is we're going to have to fetch this. Well, no, we're no longer working with images. We're going to have to fetch this audio data that we just created. Okay. Now, normally we would if this was really like a streaming service, it'd be like fetch the audio from, movie 1. But for now, we only have a single movie, so we don't have to worry about that. So, and we're just pulling this chunk that corresponds to the chunk of video that we're getting. So we can pump chunks as we want to go. So great, let's fetch this thing. So we're gonna fetch a, which is fine because it's a thenable promise, and that's thenable. So we can say this thing is really JSON, so parse it for me. All right, neat. So then after we've parsed that JSON, we can just drop that thing on console just to make sure that we got the right data. And that's a nice place to start. Okay, so let's run this and we drop it on data. There's our 128s, 127s, all that other stuff. Okay, do you not like to use async? No, we're gonna wanna, so async is a whole other story. I don't wanna focus on how you would do background fetching here. Mainly because I'm frame timing myself the bad way because I'm trying to keep this simple. So I'm trying to keep it simple. We can, as we get into more advanced versions, like I said earlier, we can go into any one of these things and we can build a very sophisticated version of it. But if we're going to get through the whole series and explain how you build an entire streaming service from scratch, I'm going to have to try to keep it simple. But, let's spend our complexity on, the meat that's probably unfamiliar to everyone. Like, I think there's well-known patterns about how you fetch stuff and whatever, but there's not as well-known patterns about how you deal with audio data or video data. There's a large community, I shouldn't say large, there's a community of video audio compression people, but it's a very small community. So let's do this. Oh my God, the Alt F4 is here. Hello, black glasses. I can read the matrix. I'm sorry. Yeah, I don't even see the matrix anymore. I don't see the code anymore. I just see blonde, brunette, redhead. Oh man, cipher. Okay, so let's roll. How you doing, Alt F4? How'd the rest of the stream go? I did promise you I'd be doing JavaScript. Look at this. This is split 50-50. This is all JavaScript. It's comment. This was our image stuff, but which is actually quite cool. I can show it to you because you dropped by and yeah, special, dude. So we're building a video codec from scratch. Actually, we already built the video part of it, and we took the first frame of video and we applied a delta to it so that we can use delta compression. We only have to do the part of the scene that changed, and we're applying that and we're getting it to work. This is the correct image. Okay, so Switch was definitely the coolest name in the series. I'm gonna have to go ahead and agree with you, but there's just so many good lines. Okay, all right. Let's not get lost. Let's not go down that road. All right, we're doing the audio because we're going for the reach. I feel epoch, yes, and the Nebuchadnezzar, come on. All right, so we have this thing on console, but we don't want it on console because we're going to be JavaScript masters. And what do JavaScript masters do? Like Alt F4 is totally a master. He does like socket IO like nobody's business. So we're going to go and we're going to take this buffer and we're going to start working with it. So right now we have a normal array because we read the thing in as JSON. We parsed it. like we just saw over here. We let JavaScript do the parsing work right here. And now we need to start turning it into the right format to be able to play the audio. Alt F4 definitely having a day. Sorry about that. I really shouldn't have brought that up. Apologies, Alt F4. Last thing I heard, he forgot. Oh, come on. Alt F4 is awesome, man. And I really appreciate the shout out. And by the way, for anybody here who didn't come from Alt F4, check out Alt F4. He's totally awesome. I don't know if I have an SO command. I should be that cool. Alt F4 stream. Yeah, look at that. Okay, we do have an SO command. I didn't remember if we coded it that night when I was having a wine. Okay, so but definitely check out his stream. He's gonna do JavaScript right. I'm gonna do JavaScript wrong. I'm gonna do it all the wrong way. Okay, so but anyway, thanks a lot for shouting out earlier. So we're processing audio. We got audio. It's coming down, and we need to turn it into something that's we don't look at audio in an array. We have to hear the audio, and that's why I'm wearing the headphones tonight. Come on, let's hear the audio. I want to hear it. Okay, so the way we're going to do this, it's similar to what we were working with the off-screen context, because audio wouldn't really participate in the DOM, would it? It's not something that draws. Audio controls draw, but audio itself does not draw on the screen, so it's not normally part of the DOM. So how do we get it? Well, we start with a audio context, which is something we can pick up from window. I think it's hanging off window. Audio context. Yeah, there it is. Okay, so we need to get an audio context, which gives us a place where we can write audio that's, going to be played by our speakers. And we're going to call that the audio context because I was feeling lazy naming. And I was using CTX, and now I'm using ACTX. Okay, and we're going to need a buffer because we're not going to write directly into the audio context. That would probably sound not good. So with that audio context, I want to create an audio buffer because it's an audio context, so it only does audio buffers. And how big is that audio buffer going to be? Well, this X thing that just came in, actually, sorry. The first, I have to specify how many channels. So we're doing single channel mono audio. And it's going to be as long as the data that was passed in, right? It's going to be that many bytes. And the sample rate, I have to specify the sample rate. By the way, I spent a lot of time looking at the Mozilla docs to thank you, MDN. But the Mozilla docs are pretty solid for looking up current standards and stuff like that without having to read the spec. So that'll create a buffer, an audio buffer that we can write to. Now, it's not anything really magical. Like if I just dump this thing out on console, it's just gonna be a bunch of zeros. Okay, so it's not, it has a little bit, just like that image thing, it has a little bit of extra stuff. So here I'm specifying the length, which is, it's 30 seconds of audio corresponding to our 30, seconds of video. This is how many samples that is at 8,000 samples per second. And I have one channel. Great. Now this, you'll notice, doesn't have a data member. And that's because it doesn't know which channel you want. So I can't just take this thing and go, give me the buffer itself. I have to specify in JavaScript, give me the channel. We're going to use left. I mean, we could use right if we wanted to, but give me the left channel. So if I do that, get channel, it's not get channel. What am I talking about? It's get channel data. We want the data option. Okay, the data option. And there it is. There's my audio array as a typed array. It's a float 32, just like I showed you before Alt F4 showed up. Okay. 8,000 is the sample rate, 715,209. So that's 8,000 pulses, pulse-coded modulation, pulses per second. So that's really low for audio data. Audio is normally, like CD quality is 44.1. If you get like a FLAC file, it's usually 48,000. That's typically what WebRTC is going to use. So 8,000 is like crappy phone call, but it's as low as I could get it that we could still kind of like hear it. And, I don't want to be too painful on stream. Okay. So right now we have all of these things. This is 8,000 times 30. 8,000 times 30, 24, all right, 240,000. It's about that much because it wasn't quite 30 seconds. It was 29 point something seconds. And that's the size of this array. Okay, so 240,000 samples we got to fill out. We parse that in JSON because we're doing JavaScript. A little commentary on JavaScript there for you. Sorry, you don't have to. There are better serialization mechanisms you can use. So this is going to be our, I'm calling this the buffer of the channel. So this is basically going to be the left channel. We could also do the right channel if we wanted to, but you know, you change the 0 to a 1 and you get the right channel. So buff chan, we could actually write into both channels if we felt like it. And this is going to be a really simple copy. Except just like we did with the image data, we're going to have to do a slight transformation. Now before, on the image data, we had to go from RGBA to RGB space. Here we have to go from this 1 byte value space, 0 to 255, to float 32 space with -1 to +1, because that's what the standard says we have to do. So we're going to say, let I be 0. Go from until I is the entire length of this JSON data of audio that we got back, and increment I. Okay, so we use a 3-part for, and we just say, okay, buff chan sub I is going to get, what we'd want to do on a straight copy is just copy it over. Except we can't just copy it over because that's the wrong format, right? If I just copy this thing over and then I write out console.log buffchan, then I'm going to end up with this thing in the wrong format. I need it to be, that 128 corresponds to 0. So let's move it to 0. All right, there you go. Now it's around 0, but it's still the wrong size. So what we're going to do is we're going to take it, we're going to subtract 128. So that's going to make it negative. Now we're going to make it signed. We went from unsigned 0 to 255 to signed -128 to +128. And we're going to divide it by 128. We're going to force it to be floating point. And that's going to put it onto the right interval. It wants to be some decimal from 0 to 1 or 0 to -1. Okay, so I do that. I look at my buffer and we're in the right range. Okay, so now for the moment of truth. We need to hook this thing up to our actual audio machinery because audio is not meant to be looked at in the console log. That's not where the audio goes. The audio goes right here. Put the audio in the ears. This won't be super loud. Don't worry. Apologies before for boosting the gain. So what we need to do is we're going to need to get another variable. We're going to need from a context, we need to create a buffer source. And that means that we're going to be filling out the audio data as we're going. So that'll allow us to manage the buffer directly in JavaScript, which allows us to do the kind of thing that 715209 was mentioning, that we can handle async, we can do whatever we want in order to be able to manage our audio data as we want. We can watch the frame rate, we can watch how many frames are being displayed, we can make sure the audio stays in sync with the video. That's an advanced topic, so we're not going to do that today. But today we're just going to pray they stay in sync. So let's go ahead and create this buffer source. So I'm going to call this the buff source very creatively. And you know, that's just, yeah, okay, cool. So buffer source, the buffer source buffer, this thing, if I drop it out, by the way, this is probably a part of the standard you haven't seen. I'm just guessing, maybe some of you have seen it. You're going to get this audio buffer source node, which has kind of most of the machinery that we're going to need in order to be able to play a file, but it has nothing in the buffer. So you'll notice there's no audio data loaded to this thing. So let's attach that audio data. Buff source dot buffer is going to get the buffer that we created earlier. So that's this buff that we were working with. Okay, so that's going to be our audio buffer. And something doesn't seem right there. Yeah, why do I want to put that in a float 32? Huh. Yeah, because this buffer source, I'm not getting this from the right thing. This buffer source, I think some of my notes are off here because this buffer source, okay, so basically I'm filling out buff_chan. Oh, buff_chan, that's right. Buff_chan is actually just one side of, it's one audio channel in the buffer. So when it's really like a view. So when I'm writing into buff_chan, I'm really writing into the concrete data that's attached to buffer. So as long as I take the concrete buffer and I attach it to buff source buffer, now I have something that I can work with. Okay, so I can take buff source, right. Okay, so this, no, believe the notes. Buff source, I'm going to connect this up to our audio context, which is already connected to our audio speakers in the right way. It's going to do resampling and all the other stuff that it needs to do to get it in the right format, and we're going to play it. Now, there's a little bit of a standard issue here because you're not allowed to do this because you can't just play audio on a web page. It has to come out of a gesture, right? You know, because that's like, you know, click to unmute, you know, all different websites use different tricks to get you to play audio, but you have to have a button that triggers this. Otherwise it could be just playing in the background. There were all sorts of annoying web pages that did that. Oh, I'm sorry. I missed a little bit of chat there. That's a lot of bits. Yep. Is Netflix doing all of this in JavaScript? Yes. But I can tell you that Netflix is doing something a bit more advanced than this. We don't write a full streaming service from scratch every day. I'll tell you that. Like, this is like back in the. All right, I'll answer that question in more detail later if you're still interested. But it is something that we're going to get to. I can tell you that like you would need to do this if you want to be able to manage your own audio buffering and your own video buffering. Will Chrome block it? Yes. Well, it turns out Chrome did block it. Are negative decimals okay, or do you need to be absolute value? You absolutely need the negatives. So you need to be on the range from -1 to 1 for all of your audio samples. Since I'm using 1 byte 8-bit audio, I'm on the range of 0 to 255, which is what the wave format requires. So I'm normalizing it in this line here to be in the right range for JavaScript, for the browser. So all I have to do to fix this problem is I need to make it a click thing. So we're going to build a little play button for us to use. So instead of calling this thing directly, let's just add a button here. Let's call this the play button. I'll spell it out. I'm not going to be fun and find the Unicode for the play icon, but you know that would be the right thing to do. Okay, there's our nice play button. Now, let me hide my my delta here. I'll just leave it. I'll deal with it. Okay, so we're gonna zoom this out a little bit. That pausing it and playing it worked. It does work. No, so 715209, this is really a permission thing. You want the user to opt in to playing audio. So the browser doesn't really care what button they pressed, but they had to have pressed something on the page. That was to try to deal with websites that were annoying, and they would pop under, and then the browser would cover. You know, back in the day of crappy web, well, they're still out there. I mean, there's websites like this, and they would start playing audio in the background. They would wait a while and then sneak up on you and play audio and do some advertising. It was really obnoxious, and you never knew when audio was going to happen. So now it's like it's required gesture from the specification. Yes, I know, but I thought there was a loophole. There could be a loophole. I don't know the specs that well. That's really a Vape Juice Jordan kind of question, or Alt F4. Nah, not anymore. It was patched. Yeah, I'd believe Alt F4 on that. He's more of an expert on this stuff. Some sites still autoplay video. You can play video like I just did before, but not audio. And that's the reason they usually make you wait. So you have to like click play, because as soon as you click play, you opted into gesture. So it's kind of a trick. It's a UI trick. Yeah, that's what we had before. We were playing video. I mean, you saw our own video. Okay, so let's just do an on-click handler for this, and we'll say do the audio. All right, so if we do that, something will run. So this is like browser language. Do you hear it? And up on the server, just because I want to try to keep things simple, it'll probably be, a bit of Python. I totally hear it. But that, I don't want the main focus to be about. I totally hear it. The code stuff. I mean, I want to build it so that we know we got all the parts. There you go. Audio in a web page, video in a web page, video delta compression.
This is really we're going to be saying more on
Mission accomplished. I'm so happy. I need to go have a drink. Okay, so let's. Oh yeah, it should sound like I'm in space. Alt F4. This is 8-bit audio. This is like crappy phone call stuff. It's like, Houston, we have a problem. Yeah. Totally 715-219. I'm digging. This is cool stuff. I mean, so to get full video, I mean, if we're gonna go for the gold, let's do it all together. Are we ready for this? I don't even know if we're ready for this. I mean, let's do it. Let's be crazy. Let's play the video. Let's just take this chunk here. This is our image player, right? This is the non-delta version of the image player. So why don't we just take this whole thing, wrap it up in a function, and just say this is do the video. Oops, that's my bad. And let's do the video. Let's do the audio. Let's get rid of this delta thing for the moment because we're not talking about compression. Are we ready for this? Are we really ready for this? I don't know if I'm ready for this. It's not going to work. There's nothing there.
Something I'll run. So this is like browser language. And up on the server, just because I want to try to keep things simple, it'll probably be a bit of Python. But that I don't want the main focus to be about the code stuff. I mean, I want to build it so that we know we got all the parts. And to see if it'll make any sense. But this is really we're going to be saying more on the overview, like conception.
Oh my God. Custom audio video codec from scratch. You saw it here. That's it. We did the audio. We did the video. We just built our own codec in JSON. In JSON. This is our own video and audio codec. This is awesome. That's it. I'm done. That done. You know what's really funny about that, Brandon? It's not so much that they're powerful. Actually, they've gone way back to what it used to be. We are just directly programming. We're managing the bits and bytes ourselves. We're counting on nothing from the browser, basically. We're like, just give me a video surface to draw bits on. Just give me an audio. Like, let me pulse the thing. I'll pulse the speaker directly. And we're doing all of that. We are doing our own compression. We are doing we're really going to do that in the next class. We're doing all of it. We are managing it entirely ourselves in the JavaScript thread. This is amazing. Yeah, we're actually going back to the basics here. Alt F4 stream. I hate on JavaScript sometimes, but then other times I remember how badass it can be for making cool stuff. Totally black glasses. I agree with you 100%. This is awesome. We have our own custom video codec. We just built an MP4. I mean, there's a bit more in the MP4 standard than what I'm doing. There's not a lot more, surprisingly. I mean, it's really just a mix of image frames, which are called iframes, delta frames, which are referred to as p frames. They allow for macro blocks, so you can actually just do part of the image instead of having to do the whole image like I just did. And they also allow more than just delta. Right now I'm just using delta, which is like, okay, what pixels changed? But they allow things like motion. For example, if you're in like a moving camera scene, most of the frame is the same. It's just like a little bit moved and then like maybe blurred. So they allow for that too. That's allowed in iframes. And they're also allowed to use frames in either direction. That's called a B frame. You can use frames that are in the past. You can use frames that are forward. But again, same trick. It's basically an iframe plus or minus some stuff. You can use other B frames once you've decoded them as well. So, but that's it. That's video compression in a nutshell. And they're also applying Lempel-Ziv on top of it, which we can do that with the Paco library. But that's the next session. You want to build a video streaming service from scratch? You start by being able to stream video. We can manage our buffers directly. We can put any we can make our own streaming engine at this point. So this is pretty sweet. We got the basics right here. We're not doing anything around synchronization. I don't want to overbill this. This could easily get out of sync. Like, I mean, if the files that I'm pulling down are coming down at the wrong rate, I mean, I need to add some pre-caching. I really need to change this format to not just be a sync. So just like this audio is really a 30-second chunk, I need to do the same thing with the video. I need to take a 30-second chunk of video with my iframes, p frame, my delta frames and my image frames, in our case, and I need to pack them into a single file, and I need to decode them at the same time that I'm decoding the audio so that I can keep sync. It's very important to keep them in sync. Nobody wants to watch like the person talking and it's behind. That's probably what's happening on my stream right now, but I guess we could just send this up there. I really love learning how stuff actually works. Totally 715209. That's how this started. I was in the Alt F4 stream and people were just talking about basically how Netflix works, and I was like listening to it. I'm like, that's totally not how it works. These are all open standards now. Like so this is a little bit more onto Alt F4's comment. When Netflix built a lot of this stuff, the web standards were not there. The browser standards were not there to do this. I mean, Netflix didn't invent like video over the internet. There was IPTV stuff for years, but to do this in a browser and to do DRM, I'm skipping over DRM because basically you take this stuff and you add some encryption on top of it, you get DRM. So, and encryption, that's really just a different topic entirely. I mean, I don't think. Anyway, I don't want to get into that. I'm putting my video for free on the internet, so I don't really mind. I'm not trying to DRM this audio, this crappy 8-bit audio here, but so you had to like. The browser didn't support like just having a surface that you could draw bits on directly. It didn't support having an audio context that you could just write on directly. That stuff was added later in HTML5. Like, I don't even think it was in the first version. Like, they had to do a bit of work to get these like buffers and channel and Even though the funny thing is this is really just exposing what the operating system does. This is actually they're really just cleverly passing it through and checking that you don't have security violations. But really, they're not adding anything. Like they're just giving you access to the hardware, basically. The only thing is like it does do resampling, so I didn't have to implement the resampling. But just like I'm doing this, there's a way you can do resampling in software. I mean, that's fine. There's enough CPU available to do it. But yeah, I mean, we had to use like Silverlight. It used to be like you had to download Silverlight. We'd do it in Flash, and we would do some of the DRM there. We were, there was a lot of restrictions from studios about content. It couldn't just be put clear on the internet. So, it was difficult, and getting that stuff through standards body so it was available in HTML5, that was a long fight, let me tell you. That took forever, and I mean, I knew, in fact, there's a guy I'm going to be interviewing. He was the head of the web team for quite a while at Netflix. He's awesome dude, and he's a hacker, like badass hacker, and I'm gonna be bringing him on the stream a little bit later, not in this series. We're gonna be doing some hack stuff, which will be super fun, but he was so happy the day we finally had a pure HTML5 browser, no Silverlight extension. He's like, thank God we could stop installing that thing. I mean, Microsoft had long since end of life it. They were like keeping it on life support, but it's just, those were long days. Anyway, dude's awesome. I'll try to get him in here. Anyway, I hope, we're coming up on 2.5. This is 2.5 hours. I hope you all enjoyed this. A lot of the magic, this is how you do the video, image, decoding, and the audio surface itself. We covered all that in this stream. We even covered a bit about delta, which is really starting to get into compression. But, when you start getting these runs of the same number, it's very easy to compress. You don't have to use very advanced techniques to compress this. I don't want to get into that topic. But the fact is, this is kind of what you need. And then you're going to add that stuff on top. Right. And then, some of the synchronization stuff you're going to be able to manage yourself as well. But you can get more advanced, like I said, on any one of these topics. You could do an entire PhD in video codecs. It's a very deep field. There's been a lot of research, but I'm trying to give you this is actually kind of this is high level, but it's pretty practical. Like this is actually kind of how it does work. A lot of the magic is in how you're going to compress it, how you're going to deliver this stuff. I mean, I'm not going to get into all that, but we're trying to build a basic CSGFlix service here. But these are the tools you need to do it. You know, we have the ability to write audio, we have the ability to write video. So next time we're going to talk a bit about compression. You know, we're going to try to cut the number of bits down. I'm not going to get too detailed on that because that's really a tough topic. But you know, enough to like, you know, we're going to work on like run length encoding and like, you know, kind of simple compression techniques, and then we might do a little bit with code books. Then we're going to get into building a UI, because now we have the ability to play a movie. We got to select which movie we play, right? I mean, that's our first movie. We have to add some more movies, and then we're going to get to the real internet, which is actually how this started. I was talking about that in the Alt F4 stream. And the real internet adds challenges because I can't just count on these things instantaneously downloading. I have to sort of buffer a little bit. How much do I buffer? How do I watch how the connectivity is flowing? How do I collect statistics on how different ISPs work? You know, how do I work on the user? Do they use Wi-Fi? You know, do they not use Wi-Fi? Who knows? Personalization, I'm still a little bit iffy on some of these topics. I think that we're probably going to collapse these into just one of them. Or maybe some A/B stuff, and then we're going to close. We're going to get more advanced on any of these topics that you're all interested in. So, what's X264? That's an encoder that's open source of the H264 codec, which is actually what this MP4 is. You know, this file here. I'm being a little bit non-specific because MP4 is really a container format. It's not a video codec, because in this file, in my movie file that my raw movie file that I started with, this was this thing. I had a video stream and I had an audio stream, and they were both packed together into this thing. Now I could do that with my JSON. I could just say, okay, here's the video is array sub 0, audio is array sub 1, and that's similar to how this works. They interleave the two so that you can keep them like as you're downloading, but basically that's kind of how it works in here. But the video part of it is H264 in this particular container, that in this particular file. So X264 is a free encoder for that, but the thing is H264 requires a patent, so we're not using H264. So patenting in H264, there's a really long Wikipedia article on it. Patents usually get paid by the device makers when they're putting it in silicon, software decoders. There's all sorts of like gray areas on the legalese, whether the patents are enforceable or not. Google, Apple, this is like, there's years of arguing about this kind of thing. So we're making our own video format, so we're not dealing with any patented tech. I can open source this later. X264 is, yeah. So when we were doing it before, when I unrolled, I took this video earlier in the stream and I unrolled it to a series of images. PNG, by the way, is patent free. It's one of the reasons I chose it. But when I did that, that was actually, I used FFmpeg, but FFmpeg doesn't do that itself. It actually calls libx264 to do the decode and turn that into individual frames. So we actually did use x264. We just didn't use it directly. It's included via library, so that's, you know, I guess we could have done that, but we used FFmpeg because I didn't want to deal with it. All right. Well, thank you everybody for dropping by. I think this was a very productive stream. I hope you got something out of it. And yeah, we're going to move on from there, just like I said before. So I guess next up is going to be compression. I might skip around a little bit on order. I might go to UI next, just because this was already a dense CS topic. So maybe we'll have a little more fun with UI and user stuff, a little more familiar with for some of you. Compression is really about doing this better. So it's about doing it with less bits. But yeah, thank you very much. Can you make it look a little harder next time? F12. Yeah, let me tell you, during the prep session, oof. A bunch of this stuff I had to figure out. I was like, oh my God. going through some of these standard docs, like trying to get 8 kilohertz audio to play in a browser. That was fun. So trying to figure out that format of float 32. See, you just get all of it, you know, but you know, I had to work pretty hard to get this stream together. Thanks to the stream. This is really cool. I appreciate that, Brandon. I appreciate all of you who caught me on various things during the stream too. Keep me honest, you know, it's fun. And I hope to see you all around. Spread the news. Tell your friends they want to learn how to build a streaming service. Come to the rest of the show.